Welcome back, guys. This week we will look at even and odd functions. And what we want to know and do, what we want to be able to do is one, we would like to look at those even and odd functions graphically. And we'll recap a little bit, and we're going to determine if functions have an even or an odd degree by the way that it looks. Number two, we will determine finally if they move in the same direction, or opposites, or maybe even neither, right? And lastly, what we want to determine graphically is whether the overall function is even or odd. So there's the degree, there's the direction, and whether the overall function is even or odd. And we'll only be doing pages 13 through 14 today. I'm sorry, 13, 14, and 15 today. Yep. Right? And that will allow us to do 16, 17 on Tuesday, and then 18, 19 on Wednesday, Thursday. So hopefully we'll be able to do a card sort today. If we don't do it today, we will definitely do that tomorrow. Now let's move on to graphically. Now if you note, these functions themselves are even. Now a couple things I wanted to highlight here was we wanted to know if how they're even, like what are we doing to determine that? So the degree of the function is even. And if you note, when we look, the direction is the same. So we want to say the direction, and we're talking about what we call here end behavior, right? And behavior. So we'll look at that a little bit more closely, and why I wanted to highlight that. Will make it easier as we move into this on Wednesday, Thursday, Friday. Now here, the degree is of the function of the first term is odd. Leading the x term is odd. The direction opposite in behavior. And so the overall function is odd. Sometimes it's not always true. So some unique things about this, let's point this out here. If you look, we're moving in the same direction. Here, and here, here, and here, and here, and here. We're moving in the same direction. So just take note of that. This is all going up. Either it's going up or it's going down. And the direction we're going, I want to point that out as well. In each case, I have positive infinity on the left, and I have positive infinity on the right, because all of these y values are positive as we move towards the right, as we move towards the left. And that's going to be quite important when we get to our topic on limits. Now, here we're moving in opposite directions with the odd functions. Okay. And if you notice, with these odd functions, they're not symmetrical about that y-axis. So that means I can't fold it in half. So let's write some characteristics here. I can't fold in half. So with these even functions, I could fold it over the y-axis and it's even. Okay? Fold it over the y-axis. and it's even. If I can't fold it over, even though it's even, then it might not be an even function overall. And we got to be careful with our words here, and I'm having to be careful as well to ensure complete understanding. All right. So here, what I would have to do in order to make this symmetrical, in order to make this overlap, which is the goal of symmetry here, is I would have to, it has to have point symmetry. Odd functions need point symmetry. And point symmetry, a good way to think about it is that with point symmetry, you literally, in order to acquire the overlapping that you need, you would have to fold over the y and then fold over x. And you'll see us do that with our card chart so we can see how it overlaps, a distinction. And that's the only way you'll get it back to where it needs to be. But we'll look at that also algebraically, like what does that mean fairly soon. So let's move on, make this a little bit smaller. So looking at this next part, let's see, I'm going to highlight blue, everything moving in the same direction. I'm going to highlight their endpoints. So this is going down to negative infinity. And that's the only one I see going in the same direction. So it's probably going to be even. All right. This is going, let's see here. And I'm going to highlight in green stuff that's going in opposite directions. So this one's going up on this end and down on this end. This one's going up and down here. All right. So what we have here, I have this function, which I can fold over. I can fold over this y-axis, and it will lay on top of itself. We call that superimposing. And so we would say that this function is even. This function moves in opposite directions. I can fold it over, and then I can fold it again to get it to lay on top of each other. So this function is odd. And this function is odd as well. All right. Now let's look at these below. All right. So if this had continued on, we don't know what it would do or anything like that, so we don't worry about that. They're going in opposite directions. Now, it may be even. That first degree term, when we look at it algebraically, we'll be able to tell easily, might be even. However, this is neither even nor odd. Neither even nor odd. In fact, the next one is neither even nor odd. They are labeled as such, but they're talking about something specific, algebraically related to the function is my assumption here. But just be careful with that. So moving on to page number 14. It says use the graph to determine if the functions are even, odd, or neither. So let's look at these directions here. So I have this function. It's going back down. It's going back up here. Down, up, and down, and down. Okay. So number 7, we're moving in opposite directions, and I would suggest, since it's moving in opposite directions, that this is going to be odd in terms of degree. It's going to be odd in terms of degree. And we're going to make this a little bit smaller here. So the degree is odd. Okay. Number 8 looks like the degree is even, because they move in the same direction. And number 9, the degree I question anything that's broken off. So I'm going to put a question mark there. I'd be careful with that one. Anything that's broken has a discontinuity. It's discontinuous. Language we'll see pretty soon. We want to just put a full stop and put a question mark and question it. Now, direction, opposites here. Directions, we're talking about that in behavior. Opposites. So I might be wrong about the degree there. Might want to go back up and fix that. I put a question mark there because it looked even, and it's not. All right. Now, direction equals same. Both of them are pointed down. All right. So finally, let's determine if they are even or not. So they go through 0, 0. That's one thing we want to see. Does it go through 0, 0? Or does it go through the y-axis? Yes, it does. Goes through the y-axis. So things I'm looking for, characteristics I'm looking for, goes through the y-axis. So I might want to write that down. So 1, does it go through the y-axis? And the second thing, 2, how is it symmetrical about the y-axis? So this question is important. It's one that's good to see. So it's either going to be, I can flip it over, left, right, doesn't matter, and it folds over on itself. Or 2, I have point symmetry, where I have to flip it more than once to get that symmetry to be effective here. So I'm going to drag this down. All right. And if I look here, I can flip this over. I don't get the point symmetry, but I don't get the folding over on itself. If I fold this over, it's not going to give me, this point is not going to be on top of that point. So this function here is odd. It's odd. We call it odd overall. All right. Look at number 8. This function has an odd degree, maybe, and it folds over. If I fold this over, right here, this peak will fold over onto this peak. This line will fold over onto this line. And this line will fold over onto this line. And so this is an even function overall. Now, if I fold this one over, it's not going to fold over. All right. Now, if I fold it over the second time down, I still probably wouldn't get what I need. So fold it over, and we'll test this one out to see if I'm correct. But I think I'm going to go without testing it out. Actually, I should just test it out. Let's see. If I fold this over, I have 3, 0. I get negative 3, 0. I have 0, 3. So I should have 0, negative 3. 3, 0. And note this is neither. And we'll go over that in the next section, what I was looking at just now. What I was looking at was the actual points here. So how does this translate to a table? So what we need to do is to look at corresponding numbers here. So the way we determine whether a function is symmetric algebraically is we determine this in this fashion. We determine that in this fashion. So for even, if I have an x value and I take the negative of that x value, I'm going to get a positive. So what I will do for you is to give you an example. So if I have a point, I have 2, 5, right? If I go look to its counterpart, -2, the x value is -2, I'm still going to end up at the same height. So do I end up at the same height? That's your question. For opposite x values. Do I end up at the same height? That's what f of -x equals f of x means. Do I end up at the same height? So let's look at number 10 to determine that, right? And then, and before we do, let's kind of explain how we want to look at this last one, like the odd part. So if I have an x value, let's say I have 2, 5, its counterpart would be -2, right? But the difference between even and odd is its counterpart, what it would correspond to, what it would match up with, that's what corresponds means, would be negative. It would be the negative of the y value. So do I end up with the negative height? Negative height. Be opposite, let's say opposite height for opposite x values. That's my question. That's how I determine. And if I can't get either one, then something is not right, and it's a neither. It's a neither. So even, odd, same heights, odd, opposite heights. So here I wish I had yellow. I don't know what happened to my yellow. Sorry about that, guys. All right. So here I have -4, and its opposite is 4. And looks like this is negative and this is positive. So it's looking like an odd function. So let's check the next one. -5, its pair, its opposite is 5. This is negative and this is positive. And technically they're opposite heights. So I have opposite x values for opposite heights. This is telling me that I might have, and if I look down, it's not going to be the same height for opposite x values. As I look down, it's telling me that I'm dealing with an odd function. This is odd. This is odd. Okay. Why is it odd? So we're going to write our answer here. You do need to write this out so you fully understand. Table 10 is odd because we can use hard shorthand here. Because opposite x's correspond to, and we want to use this language, make a little parentheses, we'll put match so we know what that word means. Match to opposite y values or opposite y values or heights. Okay, I'm gonna go and move this because we don't need it anymore. I'm gonna move it up here. All right, so let's go to number 11. Number 11, let's look at our opposites here. We have -3, so I'm looking for a +3. So -3, and I'm looking for a +3. Here, get our highlighter going. All right, -3 and +3. Oh, I see something wrong here. I have a red flag. These heights are not opposite. They're not opposite the same. They're not the same. I don't see 13 and -13. I don't see -1 and -1 here. They're not matching up, so they're not symmetrical when the heights don't match up. So how might we write our answer? So we would say something like let's get a different color here. Let's get a blue, maybe. So symmetry does not exist. Does not exist. The heights do not align. Okay. Last one. We're looking at -3, so I'm looking at my opposite here, 3. And if we look, oh my gosh, looks like the heights actually match up this time. So I have a -5 paired with a -5. My x's are opposites, but it works. So the heights are the same. And if I go through, check each one, -2 and 2, heights are the same, 0 and 0. -1 and 1, heights are the same. So I bet you figured out how to say this appropriately. So here, this is even, because so B/C, the heights are the same. And that wraps up this for right now. We want to practice with this determining if the function is odd, even, or neither. And how we'll do that, we will complete this activity together here. That was graphically, and this is the introduction to looking at it algebraically. So what we'll do is we will write this in. So our first term is, we want to say f, we want to make this negative. All right, so let's make it negative. We want to say 3 times a negative x to the 4th, okay, minus 2 times a negative x squared plus 1. All right. And if I produce positive numbers here, then if this function doesn't change, then it's going to be said to be even, but we would also need to look at it graphically to ensure that this is true. So far, I produce a function whose signs don't change if I put a negative inside. All right, so let's look at that graphically. So we want to close that window, and we want to go to the graphing calculator here. Let's go to Chrome. Take a little bit of time, but this works. And this way we can make sure we're doing this correctly. There's no graphing calculator. Because now I'm checking for symmetry. I know I produced the same function when I plug that number in, but now I want to check. So I'm going to say f of x equals 3x to the 4th. And it helps us with our algebra skills to make sure that we're doing things right when we plug that negative in. All right, and here's our function. So if we look folded over, it's symmetrical, guys. So I checked algebraically, and my conclusion is this function is even. It's even. Because when I plug the negative in, so the same function. All right, so what does that look like? What does that mean? What's different here? So let's do this for number 2. So f of negative x, I'm going to plug that in, equals negative. And I want to know, do my signs change when I plug this negative in? So I get negative 2 times negative, it's a negative and a negative, positive x cubed, my sign change, plus 3x squared minus, nope, plus 5x, right? So this is obviously odd. This is obviously odd. And I'm going to write why it's odd. So this is odd because okay, and what we might want to, so this has symmetry. It's symmetric. It's symmetric. Okay. This is symmetric, and I can go check and make sure. But for right now, let's just visit number 3 because it looks tricky. Number 3. So f of negative x equals 2 times negative x cubed. And I'll try to make sure I do this a little bit more effectively. This equals 2. And that becomes a negative x cubed, because any negative number to an odd power always produces a negative. Right here, oh my god, this is odd because the signs of terms change. So this is symmetric. It has odd symmetry. So go ahead and practice these last two. Have a good day, guys. Next class, we will be looking more at this algebraically.